Welcome back. This is the third technical video in what will hopefully become a long series in which we build up our own Linux distro. Last time, we set up our display pipeline, which meant that our application could display a solid color on the screen for around about a second before it would exit out, and that was quite a doozy. So today we're going to be adding some interactivity to our compositor by hooking in a few different keyboard hotkeys. The main one that I want to add is a way for us to exit our compositor, and that'll make it so that we can view that solid color indefinitely instead of it quitting out after a second. I also plan to add a few hotkeys just for a little bit of spice, a little bit of fun to the project, but we'll talk about those later on. Before we get into the main topic though, I've got some refactoring and cleanup that I got to talk about. So first of all, this BZ graphics, this was our BZ DRM file in the last video. I renamed it because I want to make it more focused on just graphic stuff. And I took all of the libseat stuff out of this file. That is now in its own file. So I've got my interface for it over here. It's got a very similar initialize and cleanup function. And the reason that I moved this out is because there's a lot more than just graphics that are going to use our seat. So for instance, our input. In order to read like keyboard events and mouse events, you need to open up a device, and you do that through your seat. So that's the purpose of these functions here, which are now more publicly exposed. So anywhere in our program can really call into these. So it's to open a device or close a device. Aside from that, I created this BZ Breezy struct. So in the last video, if I jump back to some older code, so we had all of these like DRM variables and GBM variables, and OpenGL. We had all these variables defined at the tops of the files. So what I did was I took all of these variables and kind of brought them up to the top level of our program, and they're stored inside of this BZ Breezy struct. So this BZ Breezy struct is defined inside of our main method. We just define one instance up here at the top, and then we take this object and we pass that into each of our initialize functions. I also added this list.c file. This is a utility, so it's inside of our utils code. This is the interface for it. This was just all copied over from another project I had, and I made some small changes to it for this one, but basically it's just a linked list with a bunch of functions for it. Our main file. So I already mentioned the change here with this Breezy object that we created, and how we've got our different initializations now. I did restructure the old loop that we had. So I now have this function up here, which is our new loop iteration function. The idea is that our main file, this main loop iteration, can monitor all of our file descriptors. And then for each one that changes, that particular file has a handle event for handling that type of change to the file descriptor. And then we've got our render function here. All right, for the input stuff. This is what we have so far. There's, just like our other files, there's an initialize and there's a cleanup. For our input initialize function, first we initialize udev. And this is the piece that monitors for hot plug events from the kernel's devtempfs. Then we create our lib input context, providing with the udev context that we just created and some functions for opening and closing devices through our seat. Those are given through this interface here. And at this point, libinput should be able to receive pretty much all event types for all of our devices now, whether the user is plugging something in or taking it out or, pressing keys on their keyboard. Then down a bit further, we do all of our XKB setup. We'll be using XKB common to convert libinput's super generic low-level events into something that's more meaningful and keyboard specific. So for now, we just create its context, pick a key map for it, and then initialize its state. And the state is what holds the current state for which keys are being pressed. And as those lib input events come in, we will be updating the state. And as a last step down here, we save off the lib input file descriptor, which we're going to be plugging into our main.c event loop as another file descriptor here in a second. All right, I added the input file descriptor to our list of file descriptors that we monitor inside of each of our loop iterations. And basically, whenever that one has an event returned, we go ahead and call this busy input process events function, which I did finally implement. There could be multiple events waiting for us. So that's why this isn't a while loop. We basically say while each event that we get is not null, so while there are events remaining, if that event type is a keyboard event, then call into this process keyboard event function. Jump over to that. It's just higher up in the file. It's a static one, so it's just file local. So this is basically saying, hey, if the super key is being held and the other key that the user just pressed is pressed down, then go through this switch loop and look to see what's being pressed. In this case, hey, is the user pressing super escape? If so, then call this shutdown method. This shutdown is actually defined over here in our main file. All it does is it changes this boolean from false to true, and this boolean is down in our new and improved event loop, which basically just says, hey, while we're not shutting down, do this loop iteration. I did have this iterator here, but I don't actually need this anymore. Anyways, let's give this a run. Give it a compile and a run. And it shows up nice and blue. I'm going to hold down super and push escape, and we pop back out here. I can check my output and error. So these GBM surface warnings are not ideal. We are releasing the GBM back buffers back into the pool. It should never get in a state where there's no free buffers, unless it can't release them quick enough. So I've got to look into that. But yeah, it works. So the next thing I want to do, though, before I look into that GBM issue, is not strictly in the compositor requirements list, but it's just a little fun thing to do. So if I jump to my graphics code, actually I'll code it this way. So if I jump to my render function, which is in my graphics code, at the very top of it, I call this GL clear, which basically clears the screen using some color. And this color gets set in one of my initialize functions. I think it's this one. Yes, right here. We set the clear color. Clear meaning wipe the screen, not clear meaning transparent. So what I want to do is I want to change this clear color using a hotkey. So what I'm thinking is I'll create just a temporary function. Like, this is not by any means permanent code. All right, there we go. So basically, I have my GL clear color defined as this array of 3 floats. Red, green, blue are the 3 indices. And I set it here. I have this color index, which determines which of these 3 colors we're going to set, 0, 1, or 2. So first I call this set color index with an integer, 0, 1, or 2. And then I call this change color, and I give it an amount that I want to change it by. So then I change the color at that index by that amount, and I make sure that it's bounded between 0 and 1. And then I set it. So if I go over to our input now, actually, let me make these functions public first. Okay, now if we go over to our input, there we go. So first we push 1, 2, or 3, and that determines whether we're changing red, green, or blue. Then we can use, this is with the super key, so super up or super down to move that color index up or down by, we're just doing 20. No, we're not, that's terrible. This is a float between 0 and 1, not between 0 and 255. Oh, there we go. That was rough. All right, let's see if it works. 1, compile. Step 2, hope this doesn't brick my computer. Okay, we loaded, that's good. I don't notice anything changing. This could be related to the GBM buffer issue, though. Let me check to see if that's still a thing. Still says no free buffers. I'm not sure why there's no free buffers. Let me go look into that. I'll get back to you. Okay, I made a fix that might work, might not, no idea. I added this isDirty flag to our top level DRM structure. And in our render method, at the very top of it, I say, hey, if it's not dirty, then just go ahead and return. So basically that just tracks to see if our buffer changed at all, if it actually needs to be re-rendered, because there's no point in re-rendering the same thing. And then in our change color method, we set that isDirty flag to true. So let's see if this works any better. I need to start that flag as false. It's running right now. There's just nothing to paint. So if I were to select red and then push, nope, still no dice. Does it quit? It does quit. Interesting. You know what? I don't think my set color is getting called. Set the color index, but it's not registering the up and down arrows. But two things I want to change. Number one, we got to initialize that dirty flag to true. Number two, is this not up? Is it the other up? Why are there two ups? Probably because these are the same color as these other ones, so they're probably the same macros then. Okay, well, that would be a dumb fix. Color one, up. Oh my gosh, that did it. That's red, green, blue. Huh. Well, sweet. And then quit. Cool. All right, I think that's about it for this video. Next time we're going to be venturing into the very large world of Wayland, and probably staying there for at least a few months as we build up all the protocols that are necessary to make our compositor actually, functional as a compositor. Also continue experimenting with the flow of these videos to try to get something that, works well. If you have any suggestions, feel free to leave them down below. And I will catch you in the next one.